This video will cover the Geometry Common Core exam from August 2015, questions 26 through 28. Number 26 says, construct an equilateral triangle inscribed in circle T shown below. So here, notice that it says inscribed in the circle. That means the vertices are on the edges of the circle. So in the end, we should have a picture that looks like this. Circle T with our triangle inscribed. And of course it's equilateral, so all sides are congruent. Because they give you the circle already, the first thing that you need to do is put the center of your compass here on T and put the radius of your compass on the edge of the circle. It doesn't matter what part of the edge you put your compass on, as long as you're touching somewhere the edge of the circle, whether it's here, 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 or here. You need to find the radius that was used in order to construct this equilateral triangle inscribed in the circle. So once you have that radius measured, we're going to take that same length with a point here, say P, and start making arcs around the edge of the circle. So center on P, swing an arc. Then put your compass here, center here, say on T, nope, not T, we already used T, I. Center on I, swing an arc. And you're going to do that going all the way around the circle. Of course, you should be using a compass, and so your construction marks will look much better than mine. And they should be more accurate than mine. I'm just kind of guessing here. So when we are asked to do an equilateral triangle, that means to connect every other. If we were to connect all 6 of these points, we would end up with a hexagon, a regular hexagon, but we want an equilateral triangle, so I'm going to take P, this vertice over here, and every other, connect them to make an equilateral triangle. Again, you have a compass in front of you, you have a straight edge in front of you, so please utilize it in order to make sure that you have a beautiful equilateral triangle. Number 27 says, to find the distance across a pond from point B to C, a surveyor drew the diagram below. The measurements he made are indicated in his diagram. Use the surveyor's information to determine and state the distance from point B to C. So we're looking from point B to C, let's choose to call this X then, to the nearest yard. So we're looking for this side of my triangle ABC, which means that I should use this big side of my triangle of ABC. So I need the length of AC, which means I have to sum 230 and 85 to get 315. So this whole length is 315. And if you can't quite see why we need that, maybe think about separating your triangles. We have 120. This is a right angle. This is 230. Then we take the big triangle, right angle, X, and now notice, because I use this whole side of the small triangle, I need the whole side of the big triangle, 315. Corresponding parts, if we have triangles that are similar, corresponding sides are in proportion. So something like small triangle over big triangle would work perfectly here. So if we go with 120 over X, it's equivalent or equal to 230 over 315. So when we cross multiply, we get 230x equals 37,800. Remember, our goal here is to solve for x, so divide both sides by 230. So when we do that, we get x equals, let's do a little bit of division here, divide by 230. 164.3478, and the number keeps going. But notice again they said to the nearest yard, so that means no decimals. I want to look at my ones place, look to the right. The 3 is telling me to keep the 4 as a ones place. So now I know that x is equal to 164. So final answer, 164. Number 28 says, in a parallelogram, ABCD shown below has diagonals AC and BD that intersect at E. Prove angle ACD is congruent to angle CAB. So I'm going to find those angles and just put dots in them. ACD, this angle here, is congruent to angle CAB, this angle here. When I look at that, I notice a Z with those dots in the angles. And we know that a Z is formed out of alternate interior angles. And the thing that forms alternate interior angles are parallel lines. And notice again that we have a parallelogram. Parallelograms have opposite sides that are parallel. So because this is a proof, we do need to set up a T-chart. The left side is statement, and the right side is reason. The first statement and first reason always come from the given, so we need to say parallelogram ABCD, diagonals AC and BD intersect at E. Given. Okay, so now number 2, because we need to talk about parallel lines in order to get alternate interior angles that are congruent, we need to state the lines that are parallel. So because I'm looking at a Z that encompasses DC and AB, I want to state that DC is parallel to BA. And the reason for that is because opposite sides in a parallelogram are parallel. Opposite sides in a parallelogram are parallel. So then because we have opposite sides that are parallel, we then know that our two angles, angle ACD, is congruent to angle CAB. And the reason for this is because parallel lines form congruent alternate interior angles. Form congruent alternate interior angles. So again, all we did there was use the properties of a parallelogram in order to get parallel lines. And then because we had parallel lines, we used those lines to get congruent alternate interior angles. And that looks like it's it.